Okay, so yesterday we started off with 1, 2. We didn't quite finish. So I think the last thing we did was a plane. Is that correct? All right, so you should have that in your notes. So the next thing, we have a couple definitions. And the first one is, I'll just write this down. Definitions. Oops, can't spell. All right, so we've got a couple more definitions. I will not, they're still talking, okay? I need you not to talk. Thank you. There's still, these definitions right here, I'm not going to, on a quiz or a test, ask you to define it and write down exactly what the definition is, okay? But we are going to talk about it, so I need you to understand what we're talking about when we talk about these words right here, okay? And the first one is collinear points. Collinear, and then 2 L's. Collinear points. The word kind of means with, all right? So what else do you see in here? You see the with. What about the linear? What's in there? What kind of geometry word is in there? One we talked about yesterday that we didn't have a definition of. Line, right? You see the word line in there? Okay, so these are points that are with a line or on a line. So any points that lie on the same line, and you can write that down. I'm not going to take the time to write it down, but you write it down. Points that lie on the same line. I think you have this definition in your book as well. Does anybody have their book open? What page is that on? There should be a little... It's on 7? Okay, so page 7, you can see the definition. Points that lie on the same line are collinear. So take a wild guess. If they're non-collinear, what do you think? They're points that don't lie on the same line. Exactly right. Okay, so let's do a quick example of this. So let's draw a line. And let's put arrows on the ends, okay? Because to be a line, you got to have arrows on there. And let's put some points. What does collinear mean? It means the points are what? On the line, on the same line, okay? And how do we name points? Do you remember from yesterday?
Any letter that you choose.
Any letter? What kind of letter? Upper, right. It's got to be a uppercase letter. So, I don't know. Give me some letters. A. Give me another one. You're just going to go A, B, C?
L.
I was trying to L, A, B, L. Okay. So there we go. So those are 3 points, and they are all on that line right there. So all 3 of those points would be collinear. Now, you could have 100 collinear points if you wanted to, okay? Well, of course, it'd be hard to label them because you only have 26 letters in the alphabet. But you could have as many points on here as you want that are labeled. If they're on the same line, then they're collinear. What about if I had a point out here? Are all 4 of these points collinear? No, 3 of them are, but not all 4 of them. You with me on that? Okay, so that would be non-collinear. All right, let's talk about another one, and that would be concurrent. Concurrent. And these are concurrent lines, not points. Concurrent lines. So the definition, if you look in the book on page 7, it says lines whose intersection is a single point. So we haven't even used that word intersection, but what does that mean? You should know what that means. If they intersect, they cross each other, right? They do this, okay? So they intersect each other. So let's draw a couple lines that intersect each other. Actually, it can be more than just 2. In fact, as long as they go through the same point, exactly right. Now, in order to be lines, what do they have to have on them? These arrows, so we'll put arrows on them all. Let's label these kind of easy, like this slanted one right here. What's the easiest way to label a line? Okay, not just a Z, but what kind of a? Yeah, lowercase, that's the key. Okay, so lowercase, so Z. Here's my weird looking Z, that's my Z. All right, let's name this line right here. Let's name this. Give me another one. L, all right. So it's lowercase. I kind of make it cursive looking so it kind of looks like it's lowercase. And then you got this other line right here. Let's name that. Give me a name. V. All right. I'll just do a little V like this. And it's, again, they're all lowercase. Like a little V and a big V kind of look the same, but you get the idea. All right. So those are 3 lines right there. Now look what they do though. They all cross at the same exact point. They intersect. Okay. That's a good geometry word. They intersect at the same point. So what's true about all 3 of these lines? These lines are considered to be what? concurrent lines, okay? Because they all intersect at the same point right there. Now let's give this a point. So where they intersect, what do you want to call that? M? Okay. And that's supposed to be a capital M, all right? So remember, a point is always a capital letter or uppercase. So that's it, all right? Pretty simple, isn't it? Yeah, these definitions aren't too hard. All right, let's see. In my notes, example 2, I said go to the digital image, and I think it's over here. So I've got some images. Look at that. See, I was prepared. And let's move this to there, and let's see what this is. All right, so this is just an example using those definitions that we just talked about. So it says use the figure to name the following 3 collinear points. What does collinear mean? It means all the points do what? On the same line. So do you see a line here that has 3 points on it that are on the same line? Do you see anything?
Yeah.
Which line would it be? Well, I think that's an L. Yeah, that's an L. Can you see it? Yeah. Well, you can sit up closer if you need to. So I could make it bigger, I guess. Can you see it right there? All right, it barely fits on the screen. But so what are the actually the 3 points then that are collinear? Go ahead.
S, V, and T.
S, V, and T. Very good. Okay, so those are. Is there another line that we know 3 points on it? We know this line right here. Is it R, S, and M? Because M's not a what? It's not a capital letter, so it's not a point. Exactly. So this is, what would I consider M? This would be what? Line M. What about the N? That would be line N. Very good. Okay. Would I call this line R? No. Okay. What's the other line on there? All right, let's look at line K. What's another way to name line K? Line RT or line TR. Okay? Everybody see that? Doesn't matter. Okay, as long as you use 2 points. Would I call this line SVT? No, because why? We only name a line with what? 2 points or just one lowercase letter. Okay? You could call it ST, right? You could call it line ST. You could call it TS. You could call it VS. You could call it SV, right? It doesn't matter what order, what points you use, as long as you just use 2 of them, and they're on that line. Okay, good. You're getting the hang of it. 3 non-collinear points. Now, you have a lot of choices here, but 3 non-collinear. So give me 3 points that what? They're non-collinear, so they're not all 3 on the same line, okay? Now, 2 of them could be on the same line. In fact, anytime you have 2 points, you could always connect those 2 points and make a line out of it, can't you? Okay, but if I have 3 points, that third point could be on the line, but it might not be on the line. So, Ben, give me one. W and R, is that 3? 3 non-collinear points? Okay, W, R, and V, right. They're not all on the same line. They're all on 3 different lines, aren't they? Yeah, so that would be non-collinear. And there's a whole bunch of options here. Give me just one more. Somebody give me one more. Okay, Sam. SW and R. Yeah, SW and R. They don't all 3 lie on the same point, so they would be considered 3 non-collinear points, okay? I think in your example, do you see the example 2 in the book? Right underneath of it, I think they give you the answers, right, to this. So there's all kinds of options, right, to this thing. Yes?
You said it's okay if at least 2 of them are on the same line?
Yeah. So I could say RSV, right, because R and S are on the same line. That's okay as long as the third point's not. So all 3 have to, you can't have all 3 on the same line, put it that way. Yeah.
How do I not know S and V on the same line?
You do know S and V are in the same line because here's line L right here. S is a point right on line L, but it's also on line M as well, isn't it? Yeah. Okay. But that kind of gets to our next point right here. 3 concurrent lines. Again, what does concurrent means? It means the lines do what? They intersect. All 3 lines, okay? 3 lines that intersect at the same point. So, what do you think, Alex?
So, I think the 3 that intersect are line N, L, and K.
N, L, and K. All right, that's good. And let me ask you this. Where do they intersect? All right, Cameron? At point T. Very good, okay? And I like she said point T and not just T, all right, because you need to say the word before it. So she said point T. All right, very good. Are there any other combinations of 3 lines? Are there 3 other lines that intersect at one point? I don't see it. See, right here they intersect, but that's only 2 lines that intersect. Right here they intersect, but it's only 2 lines. Okay, so there's only, right, it's only those 3 lines right there. Okay, so it's K, L, and N. Everybody got it? And where do they intersect? At point T. All right, good. All righty. We got some more definitions, and I think I have this as a digital image as well. No, these are defined. The only undefined ones are point, line, and plane. Everything else that we're doing has definitions. Okay, so instead of me writing these all down, I just took a picture of it and stuck it on here, so it's a little bit easier. You can write those down if you want. Let's take a look at it. You see that co again. What does that co mean, did I say? It means like together or with or on or something like that, okay? So let's look at this. Coplanar. Do you remember what a plane was? Yeah. Basically a flat surface. Basically a flat surface. It keeps on going forever and ever, right? So coplanar points. So what do you think that means? It points that are on the same plane, right? On the same surface, okay? And of course they're non-coplanar, then they don't lie on the same plane. We're going to give some examples of these in a second, like pictures of them. I don't know if they do that in the book. I don't think they put any examples, do they? Like pictures of coplanar points. But I found some just for you guys, and we'll put it on there. Coplanar lines. Now, coplanar points are points that lie in the same plane. A coplanar line would be lines that lie in the same plane. I tell you what, I have pictures of these. Let's go one at a time instead of going through all of them. So coplanar points. Let me see which one. I think this is the one. Copy that. Swing it over here. So coplanar points. I think that's, yep. And let's just scooch that down. Again, what does coplanar points mean? It means points that lie on the same what?
Line.
On the same plane, coplanar. So, do you see the plane? That blue thing right there is considered a plane. Now, this looks like it has edges, but does a true plane have edges? No, it does what? Keeps on going forever. Good. All right, so what is the, yeah, they don't give you a little letter for this. Remember I said you could name a plane with a lowercase letter? Do you see any lowercase letters here? No, but you could also, if you look in your notes, how else can you name a plane? 3 points that lie on the plane. That's right. So, does H lie in the plane? No. Okay, because this is kind of like, this plane is kind of like a piece of paper, and where HE is, what's it doing? And what's that dashed line? What's going on there? So it's basically like this. I'm not going to poke through my paper, but basically it would be going through here. It would go through the plane and come out the back end of it. Everybody see that? So this dotted line, okay, this dotted line right here, that represents the part that you can't see, right? So if I had this paper slanted up a little bit and this actually went all the way through, there's a little bit that you couldn't see. That's represented by that dotted line. And then it's solid down the bottom. Why is it solid down the bottom? Because that's the part where you start seeing it again. Does that make sense? Because it's kind of like it's slanted and you're, well, look, I don't have a big enough hole for this to go through, but, you know, it goes through like this. Yep. Okay, so that's what that is. So line HE does not lie on the plane. What do you think it does? It goes through it, but give me a good geometry word. And you're right, it does go through it. Intersects. It intersects the plane. Right, okay? It goes through and it hits at one point. Remember those 2 lines? Yeah. Remember the lines they intersected? They intersected at one point. So if a line hits a plane, it intersects at one point. What's the point where line HE intersects the plane? E, right, point E. All right, so it goes right there. So with that said, now let's go to the original question. Give me 3 coplanar points. Yeah, D, E, and F. They all lie on the same plane. Okay? There's some. Now, they're all on the same line, but they don't have to be on the same line. Okay, they can be. We're just worried that we're not worried about it, but we're concerned that they're on the plane itself. Is D, G, and E, exactly, would be another set of coplanar points. Make sense? Is there any other? Yeah, there's another set. What do you think? Yeah.
I have a different question.
Okay, go ahead.
What would G be if it's like not on the line, like just on the line?
It's just on the plane. Yep. So G is just on the plane, and it's not on this line right here. Okay? But D is in the plane, and it's on this line. E is on the plane and on the line. F is on the plane and on the line. H is just on this line right here. It's not on the plane. All the other points, this 1, 2, 3, 4 points, are all on the plane. Okay? Well, H would be non-collinear with G, D, and F, right? But H and E would be collinear because they're on the same line. See that one going up and down? Okay? All right, this is all just about language. This is about the language of geometry. That's basically all we're doing right here. We're not doing any math. We're not adding anything, subtracting anything. Okay, we're just learning some words. And geometry is full of different words. All right, so what was the next thing? That was coplanar and coplanar points. Now coplanar lines. I got a picture for that too. It's right here. Copy that. Bring it over here underneath our definitions. There it is. Okay, so what's the next word? Coplanar what? Lines. Now look at these. There's the plane right there. Okay? I could name this plane if I wanted to. Now, remember, you could name it with a little lowercase letter up in the corner somewhere, but do you have that in this situation? No, you don't. But you could name it because if you used any 3 points that are on the plane, you could name this. So if I said, name this plane right here, there's all kinds of different answers. There's not just one answer. So what is one possible answer? A, what else? Give me another one. A, D, and E. Right, they're 3 points. So really, any combination of 3 points of these right here would be on the plane, and that's how you could name it. You can name it plane. Do we have like a little symbol to represent plane when we write it out? No, what did we do yesterday? We just wrote what? The word plane. Right, we just write the word plane. Remember with line, you did have a little symbol. What was the symbol for line? Yeah, with a little line on top with the arrows, correct? Okay. So anyway, these are 3 collinear lines. Pretty easy, right? Yeah, absolutely. All right, let's see what else we got. Oops, let's go back to this. Skew lines. That's a funny word, isn't it? Skew. You might, I don't know if you've ever heard anybody say that. Usually adults, a kid probably wouldn't say that, but you say something is askew. It means it's not even, it's not lined up, it's not, that kind of thing. Yeah, so let's see what a skew line is. Oh, look at this crazy thing. I didn't draw these, I just got these off the interwebs. All right, there we go. Skew lines. Now, nothing's labeled here with letters and stuff, but we'll just say the red line and the green line, okay? Again, if you want to look at it as a box, what do these, and you probably already see the definition in there. What does it say for the definition of skew lines? Coplanar, right. So that means they don't lie in the same plane, okay? So if you have a box, I'm hooked up to my mic, so I'm not going to grab a box. Somebody grab a box for me. Jack, grab me one of these boxes. Unless there's a bunch of books in it. Are there books? There's probably books in there, aren't there? Give me that tissue box. Give me that tissue box. That'll work. Thank you. All right, so you got a box right here. I'll tuck this in. All right. So basically, it's like this. This represents right here. See this edge right here? Now, if you're watching this on YouTube, you won't be able to see it. But anyway, I'm showing a box very similar to what's on the picture there. So this edge right here, okay, would it be skew with this edge right here? Remember, what is skew lines? Skew lines are non-coplanar. They don't lie in the same plane. So look at this edge right here, and look at this edge right here. Do they lie on the same plane? Yeah, it's this front plane right here. Do you see it? So they would not be coplanar. Plus, they intersect each other. Skew lines will never intersect each other. Does that make sense? All right. But now let's take a look at this edge right here, and let's take a look at this back edge right here. See this one right here and this one right here? Will they ever intersect? No, they won't. And they're on different planes, aren't they? Okay. So they're on different planes. So this line right here could be on this plane back here, and it could be on this plane right here. Okay, but this plane and this plane are not the same, so they're not coplanar. All right, so skew lines are not coplanar, Okay, and they'll never intersect each other. All right, skew lines will never intersect. We don't really do a lot with skew lines, but with the other ones, we'll do, I don't know, quite a bit of stuff with it. All right. That was skew. Isn't that a funny word? Everybody say that. Ready? 1, 2, 3. Skew. All right. Parallel lines. Oh my goodness. We're going to be, there's a whole entire, I believe, a whole entire chapter, whole chapter just on parallel lines. Okay? So it's really important that we understand what parallel means. First of all, they are coplanar. So what does that mean? They lie on the same plane. Okay? But they don't intersect. All right? So they still don't intersect. So does that mean that every line that does not intersect is skew? No. But every line that's skew does not intersect. And every line that's parallel to each other does not intersect. But it doesn't mean parallel lines are skew lines, because parallel lines lie in the same plane. Skew lines, what? Do not lie in the same plane.
So it's skew if it's not in the skew line if it's not.
If it's not in the same plane.
Okay.
Yeah.
And it's parallel, they don't intersect.
Correct.
What if they're in
But if they're parallel, they always be in the same plane, because it says right here, they're coplanar lines.
skew lines are going to intersect?
Skew lines will never intersect. Okay? All right. Everybody with me? There's the symbol. We're going to be using the symbol a whole lot, especially in that other chapter. It's just two up and down lines right here. All right? So it's just two up and down lines. It means they're parallel to each other. Okay? And that's what it's read. The way you say it, it says is parallel to. So for instance, if you had line L and line M, and they were parallel to each other, then you would do this. So that would mean line L is parallel to line M. That kind of goes down a little bit further than the other one. They should be the same distance, but you get the idea. Okay? Let's take a look. I'm going to scooch all the way down here. There we go. Oh, no, not that one. Oh, did I have parallel lines? Yeah, I guess they're parallel. I probably could have picked a better example. Oops, didn't want to do that. I want to copy it. There we go. Hamrick. That's all right.
Do you have a sharpener?
I do not. Yeah, this isn't my room, so they don't have one in there. So I could do this. All right. I don't even know why I picked this particular picture right here, but these are maybe because they're parallel planes, but I thought I had picked another picture for parallel planes. I'll tell you what. Let's forget that picture. Let's just do my own picture. Okay? So let's do this. There's a line. And let's put some arrows on it. Okay. Guys, don't lose me. We're not done yet. All right, there we go. Look at that. Okay, look at these lines right here. I copied and pasted. So they're exactly the same line. I just shifted one down a little bit. All right? So one's not going to bend a little bit towards the other one. Everybody see that? So it just keeps on going. They go in the same exact angle. Will these lines ever intersect each other? No, they won't. Okay? So these are what kind of lines? Parallel lines. Okay? Let's spell parallel correctly, because a lot of people... Some people double the letters, double the R, but it's not. The L is doubled right here, but the R is just a single R. Guys, up here. Hey, we're not going to do that. We're not doing that. Thank you. Okay, so these parallel lines right here, they're coplanar, so they're in the same plane. Like, what plane are these in? Well, they're in the plane of my screen, okay? That flat surface right there. They're in the same plane. One's not like poking into the screen and coming out like this. Does that make sense? All right, so they're in the same plane. If you take a box, again, there's a lot of parallel lines on here, aren't there? Like this edge right here would be parallel to this edge down here. They're in the same plane and they never intersect each other, right? Where are some other parallel lines? Well, this one right here and this one right here. This one here and this one here. You got it? All right, so those are parallel lines. Okay, I think we have one more and we're finished, right? Parallel planes. And that's, I got a good picture for this, I think. Ah, there we go. Copy that. And then let's scooch that over. So what does it say? Keep going, keep going, keep going. Almost there. There we go. Parallel planes. What do you think? Parallel lines just don't intersect. They're lines that don't intersect. So what do you think is true about parallel planes? They're planes that don't intersect, right? I'll just do it like that. It's a lot easier for me to, I guess I could have drawn this, but there you go. And they even name these planes. See, they put the lowercase letter right up in the corner. So they will never intersect each other. So if I had, unfortunately, this paper is kind of flimsy, so it's not completely flat. But if I had planes like this, and if they never intersect, then they're parallel. What if one tilts up just a little bit? Eventually, they'll intersect. Now, right here, it doesn't look like they're intersecting, does it? But remember what a plane does. It doesn't have any edges. A plane keeps doing what? Keeps going forever and ever. So this plane right here would eventually intersect this plane right here. Make sense? That's why they keep going forever and ever. And one's slanted like that, and you're like, they're not touching each other. Those, planes aren't touching, but they eventually will. All right? Yeah, go ahead.
If you had to draw like parallel things, you're not going to be like super strict.
I probably won't even do that. Okay? They'll probably give you a question or something, and they'll already have the planes drawn, and they'll ask you stuff about it. Right. Yeah, exactly. Right. I really don't think. Now, this is my first year teaching out of this particular book, so I don't know all the questions that they have, but my guess is, where did I put my notes? Oh, here they are. All right, I think that's it. Is that the end of the chapter? For you guys to have your books open? I don't have the book in front of me. Yeah. So here's your homework. And, there we go. So, homework. I'll do it in red this time. Change some colors around. Usually I do a lot of colors, but I've been lazy. Let's see. So here's what I want you to do. You've got your sheet of paper, right? Here's your, let's make it a little bit bigger. About like that. Okay? So there's your paper. Right there. This is the edge of your paper. Here's what I want you to do. I want you to put your first and last name. You should always put your first and last name, okay? Don't just put Bobby or whatever your name is, okay? Put your first and last name. Don't just put Bobby H. Put your first and last name, okay? And put the date that it's due, that the homework is due. So this is going to be due tomorrow. So today is the 1st. So what date are you going to put on here? You're going to put tomorrow's date. What's that? We don't have school tomorrow? We don't? We're off tomorrow? Oh, my goodness. That's awesome. I thought we had school tomorrow. Because my other school friends that teach other schools are like, oh, I got a 4-day weekend. I'm like, oh, I don't. I got school on Friday. But today's Thursday, right? And we don't have school Friday or Monday? Oh, man, you made my day. That's awesome. Anyway, so this will be due Tuesday, whatever day that is. I don't know. This is on loose leaf paper. Yeah. Loose leaf, right? You got the holes right there. It's loose leaf paper. So first name, last name, put the date due, and then you're going to put the assignment. Now watch very carefully. Okay, here's how you do the assignment. You're going to put the section number, which is 1, 2. All right, always put the section number. Guess what? If you don't put the section number, guess what I'm going to do? I'm not going to fail you, but I'm going to take a point off, 1 point off, okay? If you don't have these things on here, that's 1 point off for each of them. You got it? If you just put your first name, guess what? 1 point off. Okay, if you don't put the date on there, if you put it on wrong, then guess what? 1 point off. If you don't put the section number, guess what? It's 1 point off. If you don't do it in pencil, it's what? Yeah, so if you don't follow my instructions, you only get 5 points for this, all right? So if you don't follow my instructions, yeah, eventually, like if you have, what if you have frilly edges, the frilly edges right here? That's 1 point off. You potentially could get a 0 even doing the whole homework because you're not following my instructions. Everybody got it?
Yes.
It's not that hard though, okay? Just follow instructions. That's all you got to do. And then we're going to put the page. So it's pages 8 and 9, and I'm going to have you do 1 to 18. 8 and 9. It starts on 8, goes through 9, and then it's numbers 1 to 18. Now, this is not drawn to scale. Don't do all this all the way down this paper. Just put it in that top little section where you got that big old gap at the top. Okay? Or you could put it in the middle. To tell you the truth, if you want to put the section stuff, right here, that's fine. I don't care. You don't have to cram everything in the top.
We did on our first 5 lines right in the corner.
Put it up at that top gap. You got that big old white gap at the very top. See the big gap at the very top?
So erase everything.
Above that, in that white gap at the top. Right. So if your lines start here, I want everything above that line. Okay? If you want to put the section in the middle, that's fine. But put your name up at the top right and the date at the top right. If you want to put the section in the middle, you can. If you think you can fit the section stuff up here, you can do that as well. All right.
What is Tuesday next week?
5. Yeah, it's the 6th. So it's due 9/6.
All right, guys. If you forget about the homework,
Okay.
let's not remind them.
All right. Forget. I would never forget about the homework. All right. Everybody good with this? Okay. Any questions, any comments on anything we've done so far? All right. Okay, that's it. Have a good 4-day weekend. Oh, man, I'm so happy now that we got tomorrow off.
Well, now that you know.
I can play some disc golf tomorrow.